Hello, this is Paul from Foresight Tech. In this lecture, we are going to discuss scientific notation. And then first, we define what is scientific notation, and then to convert the numbers between scientific notation and the standard notation. What's scientific notation? It's a simple way to write a very large number or very small number. Okay, it's just a kind of a notation. Let me first look at a large number. Okay, and then for example, we have a lot of number, so very large, right? Like 1,000 million, go to billion, trillion, 2 trillion, negative 2 trillion. This gets bigger and bigger. This is a large number. How do you describe the number in another way? And then later, we were going to see the way on the right side. I was going to write, we call the scientific notation. And the first, let me write what is another way to describe 1,000. So 1,000 is 10 by 10 by 10, right? So easy to do. So let me going to see, should it be is 10 by 10 by 10. This is 1,000. Okay, or everyone know this is 8 times 8 times 8. The same number times together, this we call exponent. We can use exponent to write, which is 10 raised to the third power, right? And then we times 10 at the beginning, which means is 1.0 times 10 raised to the third power. This is another way, okay? And you will see 1.0 times 10 raised to the third power. If you ignore 1, 10 raised to the third power, which means the exponent. Okay, the same. How about this number? This is 1 million. How many 10 times together? 1, 2, 3, 4, 5, 6, 10 times together. Okay, so you will say, you will definitely find okay, so I ignore the middle. What do we get? We also get 1.0 times 10 raised to a power. How many power? This is 6, right? If we use 10 times together to find the power, this is one way and another way. So we can find the power by another way. Can we count what is the steps we have to move for the decimal point? The original decimal point, if I say the new decimal point is at here, 1.0. If the new decimal point I say here, see how many steps we have to move? 1, 2, 3, 4, 5, 6. And this is 6 steps we have to move the decimal points. Okay, this 6 is consistent with this 6. Can we try, is this 3 the same? The old decimal point here, the new decimal 1.0 is here. How many steps we need to move? 1, 2, 3. See, that's consistent. So the same way, can we look at the 1 billion? How many steps we have to move? The old decimal point here, the new decimal point here. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 steps. So you will say, okay, by this pattern. And how many steps we have to move? So we put it to the power. Okay, that's true exactly. So what do we get? We get 1.0 times 10 raised to the 9th power, which means the power is determined by how many steps we have to move the decimal point. So how about this big number? 1 trillion. How many steps? 3, 6, 9, 12 steps. Therefore, for 1 trillion, the power is 12. Let me write down. So it's 1.0 times 10 raised to the 12. Okay, and usually we call this 3, 6, the power we call the magnitude. Okay, or the level of the big number. The magnitude is 12. 12, which means 3 trillion. 9 means billion. 6 means million. 3 means 1,000. I think we already learned this before, right? Good. So how about the 2 trillion? Of course, 2 trillion is double 1 trillion, right? So it's 2 times, therefore, should be 2.0 times 10 raised to the 12th power. So how about the negative 2 trillion? Okay, it's the same. Okay, all we need is to put a negative at the beginning of the number. So we get a negative 2.0 times 10 raised to the 12th power. Can you see all the number we wrote at the right side is much simpler than the number on the left side? Okay, so the right side we call the scientific notation. The left side we call the standard notation. Let me see. And this number we call the scientific notation. Scientific notation. And this is just a kind of a notation to describe a number, a big number in a simple way, right? So the left we call the standard notation. Standard notation. Okay, and now we summarize the method. Okay, so we define what is the exact scientific notation for a large number. So how many parts do we have? We have one part is the sign. If a negative number, we have a negative. And the second number, can you see 1.0 or 2.0? Is the second number. The second part. The third part, we have a power. Okay, so we put these three parts together. We define what is a scientific notation. So I'll write here. So we call the basic definition of a scientific notation is this. The number is either positive or negative. This is the sign. Okay, positive number or negative number. And then this number 1 or 2.0 use C to describe. And then times, and the third part is 10 raised to a power. Always 10 raised to a power we call the M. Can you see? And I put this is the definition. Keep in mind that we have a three part. Okay, so this we call it the definition. And the first part, you can see the first part is a sign, right? So we have a sign. And positive, which means a positive number. Usually positive is just ignore. Okay. Negative, which means a negative number. What is C? Or C, this is very important. It's always between 1 and 10. This is a strict limit. Okay, so it's 1 to 10. C could be equals 1, like here. Okay, but the C cannot be equal to 10. Okay, if C is 10, that would not call the scientific notation. C should be between 1 and 10. 10, this we call the base, right? 10 we call the base. This is the base. You remember the exponent, right? So this is power is called exponent, or we simply call power. This part is the power. Okay, another language you call the magnitude or exponent. But this is a positive number because we describe a large number. So keep in mind this is a positive number, integer number. Okay, so here is the definition. So we have 1, 2, 3 part for a large number. So how do you find the power? So we count how many steps we need to move. Okay, so now let me going to see what the calculator tells us for a large number. Okay, we have another way to describe scientific notation, the calculator. Let me going to see. And set up my calculator. Okay, and let me going to look at 2 trillion. Okay, so okay, and I turn on my calculator. So wait, let me tune a little. Yeah, so 2 trillion, 2, 1, 2, 3. This is thousand, right? 2000, 1, 2, 3. Million, 1, 2, 3. Billion, 1, 2, 3. See, this is 2 trillion, right? And so what is scientific notation in the calculator? 2.0, 2e12, which means 2.0 times 10 raised to the 12th power. Okay, so this is the scientific notation described in calculator. Yeah, and now let's go back. So we're going to see. Let me going to find this is the basic definition for what is the large number for scientific notation, and we're going to give an example. So I copied the definition here. And then remember, the first part is a sign. The second part is a C, is a number between 1 and 10. The third part is 10 raised to a power. How to determine the power is the positive integer, right? Determined by the steps. How many steps we need to move the decimal. Okay, so now let's practice how to describe the scientific notation. And between standard notation and the scientific notation. This is a large number. If someone is familiar with this should be 5 million, right? The level 5 million is 100,000. How to describe this scientific notation? So first, we know this is a standard notation, right? Okay, so this is a standard notation. Let me draw. Remember this. This is a standard notation. We need to convert this standard notation to scientific notation. Okay, between scientific notation. How to write? Okay, how to write this? I'm going to count the steps, right? But first, let me write. This should be determined the sign first, and then C, and then power. We have 3 parts. This is a positive number, so direct the sign is positive, we ignore. How about the C? C is between 1 and 10. So this number between 1 and 10 is only 5.6. So first, let me write 5.6. No problem, right? This is definitely only number. And then C we determine, and then we're going to the power times 10 raised to how many power? Okay, the power determined by what? By the steps we need to move the decimal point. Okay, that's the most important. The old decimal is here, decimal point. The new decimal point 5.6 is here. So from the old to new, we count 1, 2, 3, 4, 5, 6. Okay, so we need to move 6 steps. 6 steps move to remember the power is 6. So this is the answer. We already find it. This we call the scientific notation, right? Okay, one more. And then look at this number. So this time is a scientific notation, right? So let me write. And this is a scientific notation. And then we needed what? We need to convert the scientific notation to standard notation. To standard notation. Just the opposite, okay? So how do you do? This is a bigger number because the power is a positive number, right? How big is the number? We need to put a lot of zero, but how many zero you imagine? So we have to move the decimal, right? How many steps? 7 steps there. Okay, probably you can think 1. This time I move the decimal to right because we need to describe a large number. How many? 1, 2, 3, a lot of. Let me write down. So it should be 10 raised to the 6th power is a million. This time is 21 million. Okay, if you are familiar. So how many 0? 1, 2, 3. 1, 2, 3. I say this is true. Okay, so I put this and this. So you imagine why I wrote this. Because what? Because we move the decimal to the right 7 steps, definitely will get this. Or we say this. The old decimal is here. The new decimal is here. Can we count 1, 2, 3, 4, 5, 6, 7? Can you see? There's 7 steps, which means that's true, right? 7 steps move the decimal. If we move back, it's also 7 steps. So therefore, the power is 7. Okay, so this is the way we find. And let me see. And this is the very basic. Let me practice one more. We'll look at the right numbers in scientific notation. Okay, and I have different questions to ask. With their practice, the definition. Okay, so we have a sign, we have a C, we have the power, right? All we're going to do is that. And we're going to see the first. Write this number scientific notation. Why? This is a scientific notation, right? No, this is not a scientific notation. Why this is not a scientific notation? Can we say first? Okay, this is not a scientific notation because because 21 is not between 1 and 10. Do you remember this is C, right? This is a positive. The sign does not show up here, which means a positive number. So this is C, and the N is 7. So this is not the scientific notation, you know. This is not a scientific. Why? Because C is not between 1 and 10. We need to make this C to 1 and 10. So we have two ways to do. Let me go into the older way. So the original is do this way. 21 I wrote in scientific notation. Okay, so what do I get? So I can write in this way. 21 is 2.1, right? 2.1 is between 1 and 10. And then times 10 raised to how many power? Old decimal to new decimal, one step. So this is 1. Okay, so this is the first. Which means I wrote 21 as a scientific notation. First is this, right? And then I have to times 10 raised to the 7th power. Okay, so now I can merge these two like a term together. But probably someone would ask, how to times 10 raised to the 1st power, 10 raised to the 7th power. This we have a rule to use. We call the product rule. Let me write to you. We call the product rule. Okay, what the product rule means if I write this in this way, okay, is the general way, like a raised to the nth power times a raised to the mth power, and the rule give us is just add the power together. What do we get? We get a raised to n plus m. Okay, which means if we use the product, they just add the power. So this power is 1, this power is 7, add the power, how many we get? We get 8. Okay, so if we add the power together, 2.1 times 10 raised to the 8th power. Okay, this is a scientific notation. And the final one, this is a scientific notation. Probably someone, if you forget how to get the product rule, I can show you, because later we still need to use product rule. It's famous. Okay, this is the exponent rule, one of the famous method. Product rule in exponent. Can you see? And we have exponent times another exponent. What does this exponent mean? Which means a times a. How many a times together? N a times together, right? So how about this? Which means m a times together. If we order times, this is a product, right? So put it together, we have n plus m. You count n plus m a. Therefore, the power is goes to n plus m. Okay, this we call the product rule. It's super easy to understand. So, and later we still are going to use the product rule. Okay. However, this is not the easiest way to do. So can you see, this is the very old way. So we do this step, we have an easy way to do. I'm going to show another way, we call the balance. Okay, we call the balance. Let me show the new way here. Okay, I will show the new way. Let me put, I will put the way here. What do we call? That we call the balance. We call it this balance. Okay, we can use the new way, easy to find the answer. Okay. And we can go from the beginning directly jump to the end. Is this? Let me show. Is 21, right? The old 21 times 10 raised to the 7th power. Okay, and I can directly write. The answer is this. Why? So imagine. From this number first, we need to find the 2.1. Is 2.1. This is the only number I can put. I find the 2.1 here. This is the only number between 1 and 10, right? And then times 10. I don't know which one. I don't know. Is the power. What's the new power? We can use the balance to find the power. So what does balance mean? Balance means this. We have two parts. The first one part and the second part. And we will keep the value not change. Okay, we have to balance the two parts. Can we see 21 is too big. We need to go to 2.1. And this number is too big. We need to decrease this number. Okay, decrease how many magnitude? We can say is this the original decimal here. We need the new decimal 2.1 is to this. How many? And the decrease 1. Okay, what is 1 mean? 1 means 1 power or 1 magnitude or 1 level. Okay, so you can imagine now. And this part, the first part decrease 1 magnitude. So the second part should increase 1 magnitude. What is the magnitude? The magnitude is 7. Okay, so 7 need to increase 1. And then you can say 7 increase 1, we get 8, right? Therefore, the new power here is 8. So have you get it? So this we call the balance. Is very, very important. I will going to practice in different example. Okay, again, so forget about the original. So remember, focus on the balanced new way. So how about this number? Okay, 210 is too big. It's not a scientific notation. Okay, we're going to write the scientific notation, so you know how to write. Let me write it in this way. If I put it here. Okay, so first, no matter what, this only number between 1 and 10 is 2.1. No problem, right? Okay, and then is times 10 raised to power. We don't know the power. So now I'm going to use the balance to find. So this number is too big. We need to get this smaller down to 2.1. We need to decrease. You say decrease how many level? So the old decimal 1 level, 2 level, or 2 magnitude. Decrease 2. So the magnitudes should increase 2. The second part should be increased 2 magnitude. If the first part decrease 2 magnitude. Okay, so keep in mind, if both the part decrease, you will decrease the value. If both part increase, you will increase the value. We need to keep the value not change. So keep in mind, one part decrease, another part should be increase. Okay, so this is the basic. So increase 2, you can say 7 is the old. 7 increase 2 is 9. So what do we get? Here is 9. That's super easy to find. Okay, if you get it. Practice one more. How about this? Okay, this is not a scientific notation because 0.21 is not between 1 and 10. So we're going to do this. We're going to balance still. We call the balance. First, find the number between 1 and 10. 2.1, the only number. And then times 10 raised to the new power. Okay, what the new power? We need to balance, and this number is too small. This time we need to increase this number to 2.1. Increase how many level? 1. Why? Because the decimal from here should be equal to 2.1. Okay, increase 1 magnitude. Therefore, the second part decrease 1 magnitude. 7 is the magnitude. Decrease 1. So you will say 7 decrease 1 minus 1. Subtract the 1. We get a 6. Okay, so this power is 6, right? The one more. So can we look at this? Okay, so this time is the same. Let me see. This is not a scientific notation because this is too small. This number not between 1 and 10. We need to find. Okay, so how to find? The only number between 1 and 10 is 2.1, and then we need to times a power. What is the power this time? So let's balance. Okay, this number too small. We need to increase, but this time is increase not 1 level, not 1 magnitude. How many? This is the old decimal. The new decimal should be equal to here 2.1. How many? 1, 2, 3. We need to increase 3 to the first part. So we need to decrease 3 level to the second part. Balance, we call it. So you can imagine 7 decrease 3, subtract the 3. What do we get? We get a 4. So 4 is the new power. Okay, so all this is talking about the large number, and this one is important. Okay, so we call it balance. always we need this one, and this can simplify calculation for us. So now is the same way. So let's going to look at a small number. Okay, we're going to define a scientific notation for small number, and let me going to explore. So 1/10, 1/100th, 1,000th, 1,000,000th, 1,000,000,000, 2,000,000,000, like this, and then we will get a very similar definition, okay, of the scientific notation for small numbers. So first, what is 0.1? Okay, so 0.1 is easy to write this way. You know, 0.1 is 1 out of 10. Is 1 out of 10? Yes, definitely. If I write one more step, 1 out of 10 raised to the 1's power, also no problem. 10 raised to 1's power is 10. What does this mean? And this means negative exponent. Okay, and let me write here, if somehow you forget, negative exponent is this: 1 out of a raised to the n's power. So 1 out of exponent, we get a negative exponent. Okay, if somehow you forget, this is the definition. This is a is the base. Now the power is a negative n. This is we call the negative exponent. If I say this is a negative exponent. Okay, we learned this a long time ago. So all we need to use is the negative exponent. If we use negative exponent, then now the power should be equal to -1, right? And then we times 1 to the beginning. So therefore, I get this. Get 1.0 times 10 raised to the -1's power. See, and this we call the scientific notation. So can you see? It's similar. So this we call the C. This is the power. And this is the way we can find the power, -1. So the same. So how about the 0.01 is 1/100th? What does 1/100th? 100 is 1 out of 100. Okay, 1 out of 100. Let me write down. 100 is 1 out of 100. Use the same way. 1 out of 100 is 10 raised to the 2nd power, right? And this exponent, this we wrote to the exponent is 10 raised to the -2's power, as their times 1 to the beginning. 1.0 times 10 raised to the -2's power. Okay, so you can follow this way to describe all these number, but we do not exactly need this. Okay, what do we need? We similar as the large number. We counted the steps to move the decimal. Okay, imagine how we can get this -2 or this 2. Okay, these 2. So how many steps we move the decimal? The old decimal here, the new decimal 1.0 is here. Can we going to count 1, 2 steps? Can you see 2 steps? So we get a -2. Is this 1 steps? Yes, definitely. This is the new decimal. So can you see 1 step we get -1? So we follow the pattern. 1 step we get -1. 2 step more we get -2. How many steps we move for here? This is the new decimal point. This is the old. 1, 2, 3 steps. So for this question is 1,000. There is 3 steps we have to move. Okay, therefore we follow the pattern. See, what do we get? We should get this, right? And we should get a 1.0 times 10 raised to the -3's power. Okay, the same. How many steps do we need to move for this one? Okay. And the 1.0, so the new decimal, the old. 1,000,000th. So 1, 2, 3, 4, 5, 6. Okay, so 6 steps. 6 steps to move for 1,000,000th. So therefore, we follow the pattern is 1.0 times 10 raised to the -6 power. Okay, do you remember what is million? The power is 6. If it's -6, it's just 1,000,000th. If the power is 3, that's 1,000. If -3, that's 1,000th. Okay, so we can find this basic pattern. Of course, 1,000,000,000 should be equal to -9's power, right? So Can we see this should be equal to 1.0 times 10 raised to the negative 9th power. Of course, we're going to count. This is the new decimal. This is the old 1, 2, 3, 4, 5, 6, 7, 8, 9. Definitely, okay, that's 9. Definitely is negative 9 because we need to move 9 steps. The last, how about the 2 billions? Okay, of course, this is 1 double goes to 2. Okay, we can find in this way to describe 2.0 times 10 raised to the 9th power. If I ask what is a 1 trillionth, should be goes to negative 12th power. Okay, this is the magnitude. This one you can find all the power is negative, right? Because what? Because we deal with a small number. All the small number we have a negative power. All the positive number corresponding to a large number. Okay, and now we have this we call the scientific, right? This we call the scientific notation. Okay, so the original is the same. We call it standard. Okay, we call it standard. Standard notation, scientific notation. And the definition is similar. Can you see what the difference? I did not put the negative. If a negative 2 billions is negative 2.0, therefore we have there are 3 parts. Okay, the sign, C, and the power. This time the power is negative. Okay, let me write the definition. They are similar. What the definition we can find is they are positive or negative. Okay, and then C, and then times 10 raised to the power. This time different. If I put n here, be careful, n is negative, right? Okay, so this is the one. What I get? So we define this, and the scientific notation for small number. So the same. So the first is a sign, right? We have a positive or negative. And what is C? C is always between 1 and 10. So they are the same. C can be 1, cannot be 10. Okay, and the 10 is the base. And this time the power n. Okay, this time the power n is what? Is a negative number. Is a negative number. That's the only difference between small number and the large number. For large number, do you remember the power or positive? And this time the power or negative. Okay, it's all the same. Let me go into see example. Can we look at this example? I copy the definition here. So there are 3 parts. Okay, and the sign, and the C, and the power. Okay. How to determine the power? Is there move the decimal. How many steps you have to move it? You put how many there, but be sure there's a negative. Okay, these are all. Let me go and look at the first. How about this number? This is a standard, right? This is a standard. This is standard notation. What do we need to do? We need to change it to scientific notation. Okay, and we follow the way we did. Do you remember? This is small number. Keep in mind that small number we have the power negative. Okay, first. So how about the sign? This is positive, so ignore. Okay, just okay, and then we find the C. C is between 1 and 10. And the other number between 1 and 10, of course, is 6.7, the only number. Okay, 6.7 we determine first, and then times 10 raised to a power. And do you remember how to put the power here? How many steps we have to move the decimal? Hold the decimal point here, the new decimal point here. Okay, how many? I'll count it. Excuse me. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The new decimal is not here. It's just here. Okay, sorry. 10 steps, right? So 10 steps we need to move. Let me put here. we have to move the decimal point from the old to new by 10 steps. Therefore, this is a negative 10. Excuse me. Here the first, don't forget here is a negative number for small number. Okay. Now we're going to the second question. Here is a scientific notation. We need to convert it to standard notation. How do you convert it to standard notation? Keep in mind that this is a negative power, which means a small number. A very small number. And then we have to move the decimal points. Okay, so this time we have to move the decimal point to the left, right? Why? Because we need to get a small number. Okay, so let me write down. So this should be in this way. Okay, how many? Let me see. The decimal point is here. We move this decimal point to the left 6 steps. We will get a 50 here. 1, 2, 3, 4, 5, and 51. Excuse me. Someone probably will ask you, why is only 50, not a 60? Then we're going to count. Does this move 5, 6 steps? This is the old decimal. This is the new decimal point. Can we count? 1, 2, 3, 4, 5, 6. Is it 6 steps? Definitely. Okay, 6 steps. So we can get a pattern. Okay. If it's negative 6, we have a 50. If it's a negative 7, so we have a 6. And always the number of 0 is 1 less than this positive number. Okay. Why? Because we have one number to move. Okay. And so this is 5 steps, and add 1 more steps, so that's 6 steps. Okay. Keep in mind, if this is negative 6, 50. If it's negative 5, 4 zeros. Okay. This is the basic pattern. Let me going to practice one more. Okay, so here we have a few questions. How do you write the number, the small number in scientific notation? Okay, the same way. Okay, we're going to find out what is the way to balance still. But first, so we get a traditional way. So how do you write this number into scientific notation? Is the same, okay, as we did before. Can we see this is not a scientific notation because this number is not between 1 and 10. So we say this is not scientific. And but we can use the traditional way. Is this okay? 0.21 are wrote in scientific notation, which is 2.1 times 10. This is a small number, so raised to the negative. How many? Negative 1, because we need to move 1 steps. And then times this number, times, excuse me, 10 raised to negative 7th power. Okay, so now what do we do? So this is the first, right? The second associative, these two numbers together, and then we use what? The product rule, right? And these two numbers together is the product rule. we just get the product rule is this way. A raised to the nth power times a raised to the mth power is a, the base are the same, raised to the n plus m power, okay, which means add the power together. So if we add the power together, can we see how many we get? -1 add the -7 is -8. Okay, so this is the scientific notation, and this is a scientific notation. That's good. And but this is the traditional way. We said we have a new way called the balance. Does balance work for small number? Okay, so let me go on to see if balance works. Still work. Okay, so the old, so we put the original is 0.21 times 10 raised to the -7th power. I say we can directly by balance we get to the answer. Okay, why? So let me go on to see the balance works or not. So first we can write the 2.1 here no matter what. Why? Because this number, whatever we need to go to 2.1, this number is between 1 and 10, right? This is the only one, and then we need to times 10 raised to the new power. All we need to determine is the new power. We try to use the balance. Okay, do you remember what is the balance we did before? Two parts. The first part we need to do what? 0.21 is too small. We need to change it to 2.1, which means we need to increase the first part. Increase how many? See, one step move. Okay, increase 1 magnitude. We said the first part increase 1 magnitude, the second part should be decrease 1 magnitude. -7 is the older power, decrease 1. How do you think we will get? -7, the older, decrease 1 is -1. -7 minus 1, we get -8. Can we see how many we get? -8. So this is the balance. That this is way simpler than the first. Yeah, definitely, right? This is much simpler than the first way. Okay, so let me highlight. Keep in mind that it's the same as before, and we were going to practice this. Practice the balance way. Okay, to change this kind of notation to scientific notation directly. Let me see these questions. How about this? No, this is not a scientific notation because this 0.0021 is too small. Okay, what do we need to do? Okay, by balance, one part another part. So I directly wrote the first, and the odd number between 1 and 10 is 2.1, right? So I get 2.1 first, the only number, and then times 10, the base always fixed, okay, and then raised to a power. What is the new power this time? Let me see, this is too small. We need to increase the first part, but increase how many level or how many magnitude? 2.1 is the new, right? We need to increase 1, 2, 3. Or you say it's increase 3 magnitude. So the second part should be decrease 3 magnitude. Okay, so we're going to count it. The old power is -7. Decrease 3 minus 3. What do we get? We get a -10. So the new power, can you see, is -10. It's easy to get it, right? The first. Have a look at the second. Okay, and this is not a scientific notation because 21 is not between 1 and 10. So what we can do? Okay, I direct the rod. Here we the only number we can find between 1 and 10 is 2.1. Okay, and then we times 10 raised to how many power? Let me go on to see. The first part is too big. Decrease how many? I think you know it decreases 1 power, right? Why? Because the old decimal 21 go to 2.1, decrease 1 magnitude. So this second part increase 1 magnitude. Always keep one part decrease, another part should be increased. That we call the balance. Okay, so balance how many? Increase 1, -7. Increase 1, we get a -6. Okay, do calculation. So the new power is -6. this is still small. Okay, this is small number. Okay, look at the last, and this is not a scientific notation because 2100 is too big, right? It's not between 1 and 10. How do you find it between 1 and 10? The only number is still 2.1, and then times 10 raised to a new power. What is the new power? We need to look at the balance. The first part is too big. We need to decrease 2.1. Decrease how many level? The old decimal here, the new decimal here, 1, 2, 3 steps. So decrease 3 level. Therefore, the second part they increase 3 level. Okay, -7 is the old power. Increase 3. What do we get? We get a -4. So -4 is the new power. That's all. Thank you.